Video. There we go. Okay, so welcome to ITS 372. So the recording is on audio, video. Okay. All right, so good afternoon. So today, this is the second week. So my plan for this week is really just to do a little bit more scripting. So the reason why I'm doing this is I just kind of want to show you what the course is about, right? So on Thursday last week, we did a little bit of, just some basic coding. Today, we're going to go more in depth and do more problems. And in particular, I'm going to show you, I think on Thursday, I just did things like if statements, for loops, etc. But now we're going to do pretty much the same, but apply it to the OS, right? So to the Linux operating system, we're going to try to see what we can do with that in the operating system. And so that will be the goal of this week, of today, basically. And then my plan is that on Thursday, then I'll give you a lab assignment where you actually have to solve some problems. Okay, so I'll come up with some ideas. So with that, then I'm going to start up the virtual machine. Give me a second here. So hopefully by now everyone has their virtual machine. Let's go ahead. Share the VM. All right, so today I'm not relying so heavily on Brightspace, but we'll come back to it, I suppose, in a second. But let's just get started with the machine. So you should be seeing. Let me log in first. All right, so you should be seeing there it is. So there's the virtual machine. So hopefully you've had enough time to practice on over the weekend and last week, the long weekend. You practice your Linux commands. So remember, this course is about Linux. Let me close. This course is about Linux, but doing Linux not manually. As much as possible, we want to automate everything, okay? Because otherwise, that's very difficult to do. So automation is extremely important. And so today I'm just going to try to show you, and throughout the semester, ways of managing the operating system, things that we can do with it. So let's go ahead then and open up our terminal. You should be seeing Brightspace. All right, there you go. Let's maximize this window a little bit more. All right, and I'm going to navigate to the desktop. So this will not be homework. The problems that I'm going to do today, they're not really homework in the sense that I will pretty much solve them for you or get them almost complete. But then I will give you a set of problems, not many, 2 to 5, somewhere along that range of problems, and that I'll have to think about, obviously, some problems for you. So let's go ahead, and since we are here, I want to know, remember, you should know these commands, you should practice them. I want to get to the folder, so the 2022-372, so I'm going to cd ITS 372 spring 2022. Okay, and so if you remember, we did these examples on Thursday. So if I cat I can do hello world and, basically a simple print statement. If I do cat on for loops, you can see we just had a list of letters and then we iterate it through the list. And then I showed you also how to do it with a range, like an index, like you normally see with C++. And then we did an if statement, cat if. And this one is basically we had a word and then we matched it to string. So we looked at the if, else statement. So that's pretty, this course is not a programming course. So I assume you guys have taken 140 or something. You have some sense of a little bit of coding. So now, and none of these are going to be different, right? So the scripts that we do in this class, scripting by definition is not difficult. When you think of programming and you think of advanced data structures, you're probably thinking of your C, C++, Java. But in scripting, it's all about just being, it's a prototyping language. So it's all about being really fast, efficient, automation, right? Simplicity. Python is a great language, very, very, very nice language that allows us to really easily do a lot of great things. So we're going to go ahead and, now that we've reviewed those problems that we worked on last week, we're going to start looking at some other ones. Okay. So let's take a look. Some additional problems. All right, so now let's start with something a little bit more similar to what we did before, but a little bit different. So this time around, we're going to learn how to pass information to a script from the command line, right? So, we always think of inputs in a program, right? And you probably have developed a website where you had text boxes or you've written some program. I'm sorry?
You guys might want to check your mics.
Okay, yeah, I'm gonna mute your mics. Okay. So as I was saying, when you have a program, sometimes you have to pass an input to it. So usually you've learned that you run the program like in the console, and then the console is going to ask you for an input, right? So on the terminal, we have a very clever and convenient way of doing that, which is basically similar to the in C. Yeah. So if you remember in C++, you have the argv, argc parameters of the main function. And whenever you run a program, you if you pass things through the terminal, you're able to pass those into the program. So we can do something similar here in Python. So we're going to go ahead and create a script. Let's call this one sysargs, I guess. Sysargs.py. Okay, so I'm gonna import a library. So I'm gonna do import sys, and then I'm gonna do basically a equal sys. So notice the beauty or the power of Python is that you have this up here. Import, right? Import is the way that you bring in other modules. A module in Python is just really another script. You write a script and then you can import that script in. So in this case, import sys is a way of doing that, right? So you have, a module that's built in and we bring it in. And this allows us, sys just implies the system, right? So we can interact with the system. So in this case, we're just going to pass a parameter. So I'm going to say arg v1, like that. You see that? This is not recursion at all. No, this is not recursion. That would be like you know, those are more complex topics of programming. This is not programming. This is just, you'll see it in action. We're passing a parameter from the terminal. Since we are using terminal in Linux, right, it's very handy to be able to pass things. So for instance, you have a script that you're going to modify some files, but you want an input, you know, a value to be passed to them. Well, you pass the value through the terminal into the program. It's just really convenient that way. So let's go ahead and see how this would work. So the simplest thing that we can do is just print our value, right? So in this case, I'm going to print A. So notice here, now this program is ready. So I'm going to save it. Remember, Control X, Y. And now I have my scripts. Should always check the parameters. So in this case, sysargs, you know, it's owned by seed. So I'm seed here. So I have the permissions. I look at the permissions, read, write, and so on. So let's go ahead and run it. And I think here we have to type Python 3. Yeah, I work on so many computers that sometimes I forget, but let's see. So sysargs like that. Okay. And now the key thing is, look at what happens if I just hit enter. There's an error. List index out of range. And that happens because, pay attention to this, by the way, if you're not, because I've seen students always, I see this error in their reports. They just don't know why it didn't run. Sysargs expects a value, something here. So for instance, hello, you pass a parameter in. So now notice it accepted it and it took it. I do another one, for instance, let's say that I'm going to modify some files, but I need to tell it which file. Well, file1.txt. That's the file I want to modify. That parameter will be passed to the program. Boom. Do you see that? So this is really convenient, and it's a good way to start always. So you can make your scripts a little bit better. Does this make sense, guys? I lost you. Okay. Okay, so let's look at it again, right? So I'm going to run it. Let's put another one, file2. Okay, so I do this and file2 comes out. So now let's look at the script. And if you notice, what's happening is this thing here, this line of code, sys.argv1. Okay, you get it now? Okay. Yeah, so that line, basically through the system, you are able to get that parameter, which is going to be stored in argv1. This is similar to the way that it works for C. And then you store it in A here. Let's say that, and then you do the print statement just to view it. Let's try another. Basically, when you run don't say the file, but the value, and it's not being sent to the nano editor, it's being sent to the script that is running. Okay, the nano editor is just for us to view things. The script is running, okay? The file that contains the code. Okay, good. So let's try another one. I'm gonna do here B, and I'm gonna say sys.argv2. Okay, and so now, and then I'm gonna need a print. Right, so I'm going to Control X, Y, enter. And I'm going to do, now notice here, this is going to be expecting something else, right? So now if I do this, boom. So each one has a position. So file2 is 1 and file5 is 2. in that argv. So that argv comes out to being kind of like an array. So you might ask yourself, well, you know, that's interesting. What if I did, add a C here, sys.argv0? Because, you know, why does it start at, we know that in programming, a lot of coding, everything starts at, or scripting, everything starts at 0, right? So what would happen if I do 0? What's in that one? What do you guys think? Do you think this will work? And if so, what do you think should be in there? I guess we can just try, right? In this case, 0, what is 0? Look at the output. 0 is actually the name of the file itself. So if you ever want the name of the file that called that program, there you go. When might this be useful? This might be useful, you know, when you want to, let's say that this was a computer virus, for instance. Let's think. We're not talking about recursion, okay? I don't know why. I never said that we were talking about recursion. You guys brought it up. That's a recursion is a topic in programming. Just a function, it's a function that calls itself, right? But I'm not doing anything right now. This is not that, okay? So recursion is like, just to address it, because that's totally outside the scope of what we're doing. But recursion is just something like def, hello, and then you do something like print 1, oops, sorry. And then here, guess what I'm gonna do? Hello. That's recursion. This function calls itself. You see that? And then when you go in here, it calls itself. And then when you go in here, it calls itself. But that's a programming concept, not something that we're discussing right now. All right, good. So yeah, so let's stay on topic. So for instance here, let's say that I want to create, so why might this be useful? Getting the name of that file. Well, let's say that I wanted to print the contents of the file itself, right? Like a computer virus. You guys know how a computer virus works, right? So a computer virus, the point of a computer virus is to copy itself, right? And so you think about it, you know, this is some file, and this is another file. So this is the malware. This is goodware. So let's just say, I'm just going to say like ABC. That's the virus, just for the sake of argument. So the virus wants to be copied into this other file. So what it needs to do is when that program is running, it needs to grab itself. So that's file1.txt, right? It grabs the contents of itself, and then it would copy that into this other program. And that's a computer virus. It just copied itself, right? So it's just copying, propagating. So let's try to do something like that, create some behavior like that. And actually, we can do it with this little command. So now that I have this, let's go back. And you know what? I'm going to say, well, I can grab the name of the file. So then I'm going to read the file. So I'm going to do fopen, right? And what am I going to open? C, because C is the name of the file. And then I'm just going to say that I want to read it. You guys see that? And then I can do something like f.read or read lines. Assign that to, let's say code, some variable code. And now let's see if I'm successful. I'm going to print code. All right, so let's go ahead and do this one. Control X, Y, enter, clear. All right. Boom. And now, what do you guys see here? Do you think we were successful or no?
I think so.
Why?
Because we pulled all the information from those files using the system args, right?
We did,
Or
right?
is that
So
not was
if you look, now notice it's a list, right? And notice there's this character, this thing here, weird looking thing.
the
But then
new
we have
line?
our import system. Then we have our A sysarg, B sysarg, the print statements, the every line. So we, in fact, read the code, correct? Right?
Yes.
Now, what is that? I will open it in a sec. What is that \n?
It means new line, right?
Line character, exactly. And so you might, if you don't know what it is, you might think like, what is this? But then if you really think about it, every time, although we don't see it, right? Although we're not seeing, every time I hit enter, I'm adding that. So like I just added an enter and basically this got written into the file, except that the text editor is not displaying it because it takes it as an instruction to move
On
to
its
another.
own, right?
Yes. Is that clear, guys? Any questions? So again, these are just examples of things, just so that you understand the underlying aspects of this and how it works. All right, so I'm not seeing any other questions, so let's move on to the next script. So I'm going to go over and do another one. So this one is interesting. Let's see. Clear. All right, so let's go back again to the whiteboard for this one. Remember, all of the things that I'm going to do are going to be related to the operating system, right? Things about the operating system, automation of the operating system, accessing. As we will learn next week, when we formally start looking at the Linux way, we're going to learn that in the Linux way, in Linux, basically, everything is a file. Okay, so in Linux, everything is a file. And so if everything is a file in Linux, that means that scripts, everything related to programs, their configuration, etc., are going to be in files. A lot of the time, those configuration files are actually what is called plain text versus binary, right? So binary would be things that we can't really read as humans, whereas plain text just means we can look at it, we can, it makes sense to us, has semantic meaning. So everything is going to be a file in Linux, and we're also going to have log files, right? And for the system that handles the login, right, the username and passwords, there's actually two files. One file is called a Passwd file, and the other one is called a shadow file. There are two files actually associated with all users. So basically, when you have a user, let's say you have C, that's a user, and you have root, and that's a user, and then you have Mary, that's a user, right? You create these accounts. Every time you create this account, information from seed will go to the Passwd file and the shadow file. The Passwd file is basically every entry, every line in this file has information about the user. So for instance, let's say the first entry will be seed, and then it's going to say like ID is 1000, and then the bin bash, and then other things. The home directory will be there. The password for seed will be in the shadow file, seed, and then there's going to be like a whole bunch of crazy characters in here because it's encrypted. It's going to be encrypted, hash basically. It's called hash. So basically, this is how it works, but they correspond. If I have the root, same thing. Root is going to be 0, bin, blah, 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 root, password like that. Mary, same thing. Mary will probably be like 1005, bin, and then Mary over here. and then again, hashed password. So all of these things are pretty important here. So this is the idea. So before we get to playing with this file, it's important that we understand certain things about it. This is an extremely important file. If an attacker took this file, they could create a line in here. And if they create a line in here, they can access the operating system and get the root privilege, which would be really bad. So there's definitely, these files are a very critical set of files in the operating system that has very high access control. So access control is a very important terminology in security, certainly one of the central security principles in the Linux operating system. Okay, and so the reason why you have this shadow file is that, you might ask yourself, why not put the password here? The problem is a lot of programs need to access this file for other things. They need to know the ID of the user. They need to know their home directory. They need to know other things. So it's not a good idea that a file that gets access a lot, that it should contain the password. So what they did is they put the password actually in another file that will only get access when you're validating the password. Okay, and so that's a good, so basically the permissions on one and the permissions on the other can be different. We'll take a look at that in a second. Okay, so hopefully that made sense. That was clear. So now let's go ahead, before we write a script to play with this file a little bit, let's go back to the operating system, Linux. So we're at Linux. Now, very important. So I haven't really talked about the file system yet, but I will now. So if you remember, I told you the file system is just, it's also central to Linux because it is basically the organization of everything in Linux. It has to do with access control in Linux, etc. So let's take a look at, close this one. All right, so let's take a look at where we are. Pwd tells me where we are. So I'm in the root, home, C, desktop, and then this folder. If I want to go back all the way to the root folder, root directory, all I do is CD like that. If you notice Pwd now, I went up one folder or directory. I do the same. Pwd. You can see now home seed. I do this one more time. And you can see I am now in seed. If I do pwd root home, I do this one more time. And you can see I have more folders here. If I do pwd, notice I am just in the root. If I do this one more time, and then I do pwd again, notice it doesn't change. So the root here and the root here are the same, which implies that we've gotten to the top level. There are other ways of doing things. So somebody is asking me, isn't seed / easier? So let's take a look at that. So I'm gonna do, let me close this one actually. All right, I'm gonna open up another terminal. Okay, and I do pwd here, right? And I'm in home seed. So I do cd desktop pwd. You see I am in desktop. So the question was, instead of doing what I did, cd ... several times, couldn't I go directly? Yes, you can. So the way to do that, the only thing that's important about that is that if you just, whenever you want to go directly to a folder, you want to start at the root directory. So for instance, let's say that I want to go directly from where I am to the home folder, right? I want to skip seed. So what I can do is I say root home. See that? And then now pwd, I am there. If I want to go back to where I was before, I can say cd root home seed, oops, sorry, seed desktop, and then I had ITS 372. And notice that I was able to tap for autocomplete. And now I can just say, I want to go directly in there. And now if I do pwd, that works too. You guys see that? So either way works. In this case, I want to go back to the root. So I just make sure that I start at root. So that's the idea. Okay, guys, so that's basically so that's basically the idea. Okay, so I've done the command here, cd root. So I'm there now. I do pwd, I'm there. So now I want to find the passwd file that I was talking about initially, right? So I'm just going to do ls. And notice here, this is the root directory. So this is really important. It is so important that at some point later in the semester, we're going to have lectures just about this. Imagine this as a tree, okay? Imagine this as a tree where the root is kind of the root of the tree, and then you have all these branches coming out, right? And so you have bin, dev, lib, mount, root, sys, var, etc., opt, run, temp, home, which is one you've seen me use already. That's where the home directories are stored, proc, sbin, and usr, right? So all of these folders have specific, jobs. They store specific information. So bin will have like executable programs. So if we go in there, bin, and then I do ls, look at all the programs that are in there. And these are not all of them, right? You have to scroll up. So you see these are all the programs that you have in Linux, basically. All those little things that you run, basically, right? They're just little files that are made executable, and then you can take a look at them here, right, and run them. And so we can do ls-l, right? And we can see their permissions, who owns them. Notice that they have the execution bit, and that allows you to run these. Okay, so all of this is pretty important. All right, so now that we're here, let's actually get out. So cd ... clear ls. Now in here, I want to find those user and password files. So the way this works is that passwd and user are technically like configuration files. They have to do with configuration. So they're usually stored in the etc folder. So I'm going to go to cd etc ls, and this is where I have a whole bunch of other files. And if you notice here, passwd is stored there, right? So that's the file in question. Scroll up a little. Here's the shadow file that I was talking about, and so on. So there's all the file, and there's many more. So every program basically in Linux, that is configured may have some folders and files in here related to configuration. Now, of course, we will not have time to evaluate all these programs, but we might evaluate some of them, okay? All right, so now we are there. So now let's take a look at the actually, let's do ls-l passwd. I just want to look at the permissions for that file. So there it is. So the passwd file is owned by root. This is very important because access control says that only root can access this file. We also, now, well, that's not true actually. So root owns it, but then the permissions are here. So the permissions say anybody can read it because these three imply the owner, these three imply group, and then these three imply everyone else. So group just means this is the user, this would be the group. And then the other one is everyone else. So pretty much we should be able to access this file because we have that R permission in there. However, the W permission for writing is only allowed for the owner root. So we cannot change this file directly. Okay, guys, but we can read it. And there are no execution bits. So the X is not there because this is not a program. This is a file, so it should not be running. Okay. All right, so let's go ahead then now and take a look at it just from cat. So I'm going to do cat, and I want to look at this file. So I'm going to do passwd, and you can see here there's some data about users. This is the data about users. So the very first line, if you look, is the root file, right? And you can see there some important data. I can probably look for the seed file somewhere in here. Should be here. Or the seed account. Fourth from bottom. All right. Oh, there it is. Yes, thank you. So there's the seed account. Notice the seed account has an ID of 1000. That's pretty important because that's your ID. Your name is kind of not as important as the ID that you're assigned. Notice in here it says that your home folder is that one, and you can, whenever you want to run commands, when you're logged in, you should get a bin bash, which allows you to execute scripts. So now let's go ahead and what do we want to do? So we have the file, just to kind of show you, I'm logged in as seed. And so if I want to see who am I can just say, who am I? Did I misspell it? All right, it tells me I'm seed. If I type ID, notice in here, it tells me that my UID, my user ID is 1000. And if I compare this to this one here, you can see that in fact, it is 1000 as well. Anyway, that's the file in question. Now let's go ahead and access this file through automation. So what I'm gonna do now, one important thing is do not write scripts in here, okay? etc and bin folders, they are only for storing like system important files. Okay, whenever you write a script, you should write it on your desktop. So now let's navigate to the desktop. So let's say what Karen said, and let's just directly go to the desktop. So home, seed, desktop, ITS 372 tab for autocomplete. Boom, we're there. I'm going to do clear ls. We're back to our scripts. Now this is where we're going to write now a new script that will access that file. So let's go ahead and do that. Nano, and I'm going to call this one read passwd. Read passwd.py. Okay, so I'm going to open this file. And I'm going to say, just like we did in the previous script, I can read it. I have permission to read it, so that won't be an issue. Now I need to specify the full path. So I'm going to say etc. No, actually, let's do this. If I just do passwd, right? I just do that. Let's just do that for now. And then comma R for read. So now I'm going to say for line in F, which is the file handler dot read lines. 1, 2, 3, 4. So then I'm going to do print line. So this will allow me to print out line by line. Okay, if I want to do this kind of see one line at a time, I can do input here. The input just allows me to kind of like pause, hit enter. You know, I have to hit enter every time. I could also take a value like X equal and enter it, but I'm not really, I just want to pause it here. And then now one thing that I should have done in the previous script and I will do in this one is when you open a file, you should close it. Definitely close it. So f dot close. So now let's just add a little print done to kind of indicate, that the script has come to completion. All right, so let's take a look. All right, so notice that the way I wrote Passwd, right? So now let's do. All right, so now I'm going to go here and I'm going to say Python read Passwd, hit enter. Oh yeah, Python 3. Boom, it says no such file or directory. So what do you think? What do you guys think happened with that? Why did it not work?
Maybe the file path wasn't specific enough. It was not specific enough.
That's right. Where is it looking for the file currently?
Passwd, and it's not. We're looking for a read underscore password, not passwd. We need the read underscore passwd.
So what happened is that currently it is looking for the file in the current working directory. Yeah, it's looking basically here, right, in this folder. It's looking among these files, because when you don't specify a path, you're just looking wherever the file that's running is located, okay? And so what I needed to do for that script is to be more specific and tell it where the file is located. That's why I went to all the trouble a few minutes ago of showing you all that. So then you have to say, /etc/passwd. We know because we went there and looked at it that that's where it's located. So now I'm going to go ahead and run it again. So read Passwd like that. Again, I keep forgetting. All right, and you notice that it only currently, this was the first line of Passwd. So it only really looked at the first line. If I hit enter, it shows me the second line, third line, fourth line, and so on. You see that? So now I can view everything. What's great about this is I can start parsing this file as well. You guys see that? And there's seeds. So let's say, for instance, that you have a whole bunch of accounts. So these are the types of problems. So now this is a type of problem that you might get in an exercise, right? The question is, you have currently the account doesn't exist. So we're gonna use seed. But let's say that you had Mary, Tim, Bob, David, right? You have all these accounts in there. You want to look for the accounts, but you want to find the ID of that person, right? So how would you do it? So in this case, if we run the script again, we can look, okay, we look for a pattern. One pattern might be that everything is separated by what? What's the separator for all the fields?
The colon.
The colon, that's right. So we can split on colon. So if we do a split on colon, we're going to get an array of cells. What's going to usually be the contents of the first cell of that array for every line? What will that be? The username. Very good. The username. The next one where you see an X, that's usually the password, where that implies that the password is located in the shadow file. And then if you notice, the third one is the ID. So if I want the ID, all I have to do is I have to get cells 0 and 2, look at the cell 0 for the account that I'm looking for, and then give back cell 3. Does this make sense? Okay, great. So now let's put together no, colons don't make arrays. Colons will be used to split a string on colon so that then we can get an array of the values in that original string. Okay, so let's try this. We're gonna split a string to make an array of values. How did I exit? Didn't get that last question, but let me just do the example. Now we're going to put together the two scripts that we had before. Okay, guys. So let's go ahead and I'm going to take. So I want actually my sysargs script, right? I'm going to use this one, right? So I don't, I'm lazy. I don't want to type. I don't like typing. So I'm going to copy that script and generate a new one. So I'm going to say CP sysargs. There we go. I'm going to copy the contents of the original one into a new file, and I'm going to call the new file. What am I trying to do? Oh, find ID user, right? Something like that. .py. So I created a new script, find ID user from sysargs, and then that way I don't have to create it, or I can just copy it. So now find ID user is what I'm going to work with. I'm going to do ls nano find ID user. Now I'm going to modify it. I don't need all of these anymore, right? I really just want one because I want to give it like this. Then I'm going to say, I don't want to print all of these, right? I just need one. And then all of this I no longer need, right? So I just want to use the sysargs that I copied it. I'll be able to give it a username. This is going to return my ID. Okay, so what else do I need? I'm going to look for this in the, so basically what am I doing? If let's say that somebody, your boss said, hey, I want you to go to every server in our company and find me the ID of this particular user on every server for whatever reason. That's kind of what we're going to do. So instead of you doing it manually, you could run a script for this. So in this case, I'm going to try the first thing I need. And this is for Linux, of course, because this is a Linux class. So I'm going to do fopen. And then I'm going to say etc passwd comma R, right? So this is basically the file that I'm opening. Now I'm going to say for line in F. Notice that I'm combining the two scripts basically. All right. etc is a directory. Remember, I showed you etc is a directory. Very important. You should never I want to stress you should never mess with those folders, okay? Like changing their names. You should not put files or scripts in etc or bin. You should always just use like your desktop somewhere. As we will learn next week, everything is a file in Linux. You guys have administrator privileges on these machines. You can easily mess up everything. So be very careful, okay? But here we're just reading. Obviously, the access control will not let you overwrite files if you just stay as a regular, with the regular status of seed, but you can elevate seed to the root privilege with the sudo command. Anyway, so we're trying to find an account, right? The ID of an account. So I'm going to do for line nf dot read lines colon 1, 2, 3, 4. And then now comes the new logic, right? So what do we need? I already have the user. It's an A, right? I'm going to pass that parameter. So now I know how to read the lines. Great. So what else do I need? I'm going to create a temp array. Temp array, that's it. And then for every time I have the line, you saw how we had the line and we were printing it. We can still print it if you would like. Print line here. So we can do temp array line dot split, right? And that's basically all it takes. In here, we're going to split this line on colon. Remember, colon we saw was the separator that we had available. All right, so now if I do this and then I just print, temp array, right? Now I'm going to add that input again just so that I can see what I'm doing, but you will be able to tell that I'm splitting. So now I'm going to do Control X, Y, and Python over here. Okay, I'm supposed to pass a parameter, so I'm going to say seed, right? That's the account that I'm looking for. It should return the ID 1000. So I'm going to say enter. Now notice here, it grabbed the first line, it split the line on colon, so now it created a list or an array, if you want to call it that, with all the values. And notice that they're going to be consistent. So I do another one, users in the first one, password, shadow password is in the second one, and the ID is in this one, and so on. So now it's pretty straightforward. I'm just going to I'm going to kill this. Do clear over here. All right, so I'm going to go into my script now. So I don't need to print this anymore. That's not, that was just for me to kind of figure things out. But what I definitely want now, I also don't want the input anymore because I want to be fast with this. Instead, I'm going to say ID. I'm going to initialize that as a blank ID, but that's going to be the value I'm looking for. So now I'm going to say if A, which is the parameter that I'm passing, equal to temp array, and which one is the index? The first one, correct? So that's going to be 0. Colon. So if I find the ID, if I find the name, what underscore? I'm sorry. Isn't it there already? I mean, it's here and then here, correct? All right. So I compare the value to the cell. Okay, yeah, I don't know if I move. I'll move it down. It's there, it should be there. All right, so, but good eye. All right, so now, if there's a match, 1, 2, 3, 4, if there's a match, then assign the ID to ID. So the ID is going to be located in temp array, not 0, not 1, but 2. Okay, and then that's it. Once you find it, oops, sorry. Once you find it, you can just go ahead and print ID. And that's it. That's your little script. And so this is the type of, when I say you're going to have to write scripts related to the logic of Linux or automate processes, this is an easy one. Later on, it'll be more complex things like, instead of this, I will ask you, okay, here's a list of 30 people, their names and everything, automatically write a script that automatically creates accounts for them, okay? So that's kind of something, but that'll be later. All right, so now let's see if it works. So I'm gonna do, oh, yes, F close, good one. I always forget that actually. So let's close the file. So I'm gonna do F dot close. Like that. Now I'm going to do Control X, Y, enter. And I'm going to go ahead and run it. Remember, I have to tell it which account I want. So in this case, seed, it should return 1,000. There it is, 1,000. I can simplify the script so it doesn't print out anything. So I'm going to take out the print line. Where's that hello? Why did it print hello? That's interesting that it did that. All right, Control X. Where's that hello coming from? Yeah, in a sec. There it is. So it prints out the 1,000 there. Yeah, so why was, somebody asked, why was it 1,000? It's 1,000 because 1,000 is the ID associated with seed, and that's actually what we were trying to do. Yes. So one quick way that I could visualize that probably. One way that I could visualize this probably is whenever we find it, let's say, whenever I find a match, let's actually print a line, and that'll give us, this will give us, so that we can match it. So Control X, Y. So it gives us 1,000 because what we're doing is, remember, this is the line we get. We split on colon. We look for this when we match seed to this, then over here, boom, we have we found it. Let's do another version of this. Let's do root. What should be the answer for this one? What should be the answer for this one, guys? 0. Very good. Exactly. So if I do that, boom, there it is, 0. Because it's root and the value is 0. And that's it. So are there any questions on this problem? No questions? All right, so yeah, so they asked me to reopen the script. Yeah. Now I am also, I am recording it, so I'll post this video and you can always just look there. But let's take a look at the script again. And let me just clean it up a little. There we go. So that's the script. I'll leave it there for a couple of seconds. All right, so let me know when you're done with the script. Okay, so now let's save this one. So we're done with that. Let's try another thing. So let's say now, we're just, like I said, today I'm just playing around with the operating system. We're automating tasks that we can do on the operating system. Another common task is what is called directory listing. And that basically means that you have a bunch of files in a directory and you want to kind of view what you have in there, right? So for this, we're going to use another library called the OS library, which allows us to get access to the folder structure. So let's go ahead and do that. I'm going to create a new script. I'm going to call it directory listing. Why not? Directory listing. .py. Okay. So I'm going to do nano directory listing. And then the objective of this is to have access to all the files in the operating system, in a directory. Now you could easily make this to navigate the entire file system. Okay, so you could start at root and just go through everything. And I may actually, that may be one of the problems on Thursday, right? But today I'm just going to show how to do a directory listing of the files in here, okay? But I could easily tell you to look at every file in the file system. Now, because let's say, for instance, that I want you to find, let's say you wrote some code, right? So many years ago, 5 years ago, you wrote some C++ code on this operating system. You know that code is there, but you don't remember where you left it. You could then iterate through the entire file system, open every file, check it for something that you remember about that code. Maybe you wrote your name on it or a date or something like that. And then when you find it, it would tell you the path of the file. That can easily, you can do that with this. Obviously, that will be a little bit slow. And actually, Linux has some built-in commands for doing that more efficiently. Something called the grep and awk command, which will be something that we will take a look at a little later in the semester. Okay, but anyway, I'm just kind of motivating uses for this. But for now, we're just going to keep it pretty simple. But just keep in mind, this might be one of the problems that I extend on Thursday. So the key thing is you want to, for now, I just want you to print out all the files in this current working directory or folder, okay? That's literally all I want to do. So I'm going to do for line in, and now here we need the module OS dot. This module then has a function called list dir colon. Now we need to specify here what path we want to list. So here we specify a variable path. which means we have to define path, okay? We'll have to define path. Now we're in here. And then of course, we need to define, so don't forget the indentation, 1, 2, 3, 4. Now we have to define in here what we want to do. So for instance, let's say, well, let's just say print hello for now. Print hello. Let's kind of work through this problem incrementally. So let's say print hello. Now, what is path? I'm going to go to home, seed, desktop, ITS 372. And I think this is called it spring. Yeah, you can see it up there. It's lowercase. 372 spring 2022. Okay. So that's my folder. And let's do 372 here. And actually, because I'm not entirely sure how this is going to work out, I'm going to say, I just want to print actually. What does OS list path give me? So I'm not sure. Let's say. I just don't know. So you know what? I'm going to do os.list. Usually Python, these functions that we're going to be using this semester will basically just give you a list. Every time it just returns a list, which you can think of as an array. All right, so now notice I have a tendency to add these spaces like to the left and to the right. That's not something that's required. You can always write it like that. But I just happen to like doing this for clarity, all right? It helps me to not miss a parentheses and things like that. So that's just my own habits, if you will. All right, so let's run this. Let's take a look. Let's see what happens. Maybe it'll break. Python 3. All right, there you go. So what I care about is that the list gives the OS list dir gives me that. You see that? So it basically gives me the names of the files, in that directory. That's really what it gives me. So then what I can do is now my goal is to read the contents of each file. Remember, I'm looking for a particular file. So I have to grab every single one of these files and look for something in it, and then basically return the path where that file is located so that I can find it, right? I'm looking for something. Now, as I said, what you might have to do is just do this for the entire operating system. All right, so let's go ahead, and I know where these are. So now I need to access each one and read it. Okay, so that seems like an interesting problem. So how do I do it? So let's go back to the script, original script, directory listing. And then I'm going to say, well, I know that this gives me, line is actually a file. So file name. I'm just writing this to be a little bit more meaningful for me. And then now that I have this, I want to get the full path so I can read the file. So what I'm going to do is I'm going to say full path equal. So for each one, I need to join the file name and the directory over here. So I'm gonna use a built-in from OS, built-in module, OS path path join. Okay. And so OS path join, and this is going to take two parameters, path and file name. You guys see that? So this will link these. And now it would be recommended to just print it out in case we made any errors. You can see what the error might be. So I'm going to full path it here. And then now I basically have this. So now I can go ahead and read it. But let's just run it. Let's just take a look and see what happens. All right, so I'm going to do this one. Now I'm ready to run Python 3. Aha. So it worked, actually. Well, no, yeah, it worked perfect, right? So it formed every single file and its path. So now that I have this, I am able to open these files and read through them. And then let's just take a quick pause. Let me grab some coffee. Give me a sec. Oh, sorry, but my throat gets really dry if I don't. All right, so now we know we can grab the file, right? So we know that. So that's really great. So now let's go back to the script. Okay. And now we need to remember, we need to find a particular file. So now we are going to say, now one thing that's important, before we read the file, we can actually check to see if it's a real file, right? So we can always check to see if it's a real file. So we can do something like if os.path. Is file. So this little function actually will tell us if the thing that I'm looking at is a file. So we do if os path is file, and then we can plug in here full path. So what we're doing here is kind of an if statement, a Boolean check. So we're saying if is file, then it's going to return true, which means the if statement will continue. If it's not a file, it's going to return false, so it's not going to execute the code. So this just avoids like errors, etc. Why is this useful? Well, you're going to be iterating through the entire file system in your homework, right? Imagine, I'm not saying it's going to take an hour, but let's say it's taking a long time, and for whatever reason, one of like thousands of those paths was incorrect. If it errors out, it's going to break. And so at least with this, it's not going to read anything that is not a file. And so that, you know, it helps you to avoid errors and mistakes. So now that you have this one, 1, 2, 3, 4, you know, if it's a file, now I'm ready to open it. So you're going to say if open, what do you open? Full path. What are you going to do with it? Just read it. Just like that. Okay, guys. And then, so once you open the file, this is now just very similar to the thing that we did in the previous script. Notice how I'm just like putting together a whole bunch of scripts together, right? Into one. So now I'm going to iterate for line in f.readLines. So for every single file, I'm opening the lines and 1, 2, 3, 4. Now I'm going to say print line. Just for now, print line. Keep it simple. I'm only like gradually doing this, right? So this should, in theory, show the contents of all files. So let's go ahead, run it, see if it works. You guys think it worked?
Yes, I think so.
Yes, exactly. So we were able to read. Yes. So we were able to read every file. Now imagine we can do this for it. Now, the key thing is I'm looking for a particular file, right? So let's see which one. You know, I wrote this script. Okay, you guys tell me a file that we need to find, and tell me what thing we could look for in that file that allows us to find it. What do you think? Do you understand my question? So we're looking, imagine we're looking for a particular file in the whole file system, but by something in it, something we've set in it. So I need a term. Okay, a lot of them can have if statements, though. That might be a problem. So that's going to give us multiple files, right? So think of something unique in one of them. Hello. Is hello in any of these? It is in one. Oh, Windows, right? Yeah, Windows is a good one because I think it's only in one of the files. So let's do Windows. You guys can try something else if you'd like. All right. So let's see. All right. So now let's go. Now let's go and we need to find the word. So first of all, we need to provide it, right? So how do we provide it? We already learned a technique called the sysargs technique, right? So what do we need for that? We need sys. So I'm going to add import sys. Notice I'm adding more modules now. And then in here, I'm going to say sys dot argv and then 1 and then term. So the term that we want to search is going to be over here. So I'm going to do this. So I have the term now. Yes, I need to do the F close. Good catch. And actually this is that Karen brought up that I forget the F closes for sure. Make sure you do that here in the loop because you're going to be opening and closing a lot of files. So definitely here, I strongly recommend that. So thanks for that one. All right, I got the term sysarg v1. So all I have to do now is the same thing as before, right? I'm going to be getting every line and I need to look in that line if it contains the term. So something I can do is if term in line. So that's how easy Python can be, right? So now that I'm going to check if I find the term, in this case, I think somebody said Windows, then 1, 2, 3, 4. What do I have to do? If I find the term in the line, just print. This might print several times, but doesn't matter. So print full path. And that should be it, if I'm not mistaken. Should be that simple, I think. All right, so let's go ahead. All right, and actually, I want to remove some of the prints that I had. So, because that's just going to be confusing. So comment that out, comment out the line. We really just want the full path. So now let's go ahead. All right, clear ls-l. Directory listing, and now I'm going to say Python 3. Boom. Error. Oh, yes. I need to provide the term. Found it. According to this, the file if statements contains Windows. So now I'm going to say cat if statements, tab it. There it is. Found my file. That's it. Notice that you could also find, this will actually return multiple files, like any file that contains the term that you're looking for will be returned. So someone had said hello, right? So let's do hello. Boom, there it is. Hello world. We do hello world. There it is. Contains the word hello. Now keep in mind, as I said, grepenoc also does this. It's going to be much faster than a script. Linux is actually always the built-in scripts of Linux are almost always going to be faster than any script you can write, just because, like, you know, Linux has a lot of things, as we will see later on, for like data analytics. So you can do like sorting of data in the command line in Linux through piping and all that. We'll take a look at all that later. We can combine Linux commands, pipe them into scripts, take scripts, pipe them into Linux commands. You create basically a pipeline in the command line, but that's a more advanced topic, which we will explore a little bit later in the semester. Okay, so hopefully that made sense. So remember, one of your first homework assignments will be basically this script, but now iterate through the entire file system. So there's a little bit more that you'll have to think about for that one. Okay, before I move on to something else, are there any questions? Okay, doesn't sound like there's any questions, so let's move on then. Now, other things that we could do, since I have this script already, let's actually just add something else, a little bit more. Let's go back to this script. Where was it? This one, right? Let's say that not only do I want to find the term, but if I find the term, I want to replace that term with something else. So for instance, in that file that where we were looking for the word Windows, we want to change the word Windows to the word Mac, from Macintosh or Apple Mac or something like that. So how could we do something like that? So in this case, we're gonna try something else. So I'm gonna add a new library. Add a new library. And I'm gonna say import RE, okay? And now this will allow me to replace something in that line. So for instance, I found a term, great. So if I found it, now I want to replace it. So I'm gonna say line equal re.sub and I'm going to try to replace Windows or term, actually, because term with Mac, for instance, right? And then we're going to print the line. So let's just see if this works first of all. Print line, Control X, Y. Python 3. Oh, yeah. Windows. And missing required string. Oh, yeah, that's right. So obviously I need to tell it where to look. All right. Should work. Found it. Right, it replaced the whole thing. No, no, it should. Term line. Replace term with Mac. Another way of doing this might be line dot replace term Mac. Should be this. It did it, right? This time it did it because if we look at the file if statements, Windows appears here and appears in the elif. So if you look, we took the line and we replaced the Windows part with Mac. So that's why this one says elif a Mac. Now we've only done this in the line, but we haven't done it in the file, right? So the question now is, how do we replace the line? It's the file itself, right? So how would we replace the file itself? So in this case, we really have to overwrite the file, basically, right? So we would have to take all the lines, save them in a list maybe, and then overwrite the file so that we can exchange it. Does that make sense, guys? Okay, great. So that will be your second problem for your homework assignment, okay? So the first problem will be to use the simple directory listing that we discussed to kind of find a term. Second one will be to create find a term and replace it. That will be the second problem. So actually, since we're running out of time for today, I'll do a couple more scripting examples on Thursday. Right, so today's the lecture. So today I'm just kind of going over examples. On Thursday, I will officially assign the homework. So on Thursday, I will officially assign the homework. And it'll be due a week from Thursday. Okay, so if this is not due Thursday, this will be due a week from Thursday. Got it? Great. All right, so I don't forget though, let me go to Brightspace in the time that we have remaining to start writing out these problems. So let me open up Brightspace. Spring 2022, and we're going into 372. Okay, let's go into content. So you guys should be seeing Brightspace now, I believe. All right, so we are in, this has been covered, right? So this was covered last week. So then we are here, background and software. We're kind of going over this today. Homework, let's see. Yeah, so this is what this will also be. Write a Python script to gather 10 pieces of information. Okay, I will, I need to update this. I wonder if I can edit here. Oop. And then I have this one. My document. Okay, so let me, what I'm going to do is I'm going to merge these two files into one. I'm going to download that one. And I'm going to download this one. So I always change the problems. So this semester I'm going to change them again. Okay, so now okay. So all right, so I'm going to delete this one. And I'm going to delete this one. Okay, and now let me share the Word document. Oh, here it is. Okay, so you should be seeing the Word document. So one of the problems is write a Python script to gather 10 pieces of information. That will be on, I will discuss this more on Thursday, but let's add a few more. So the ones, another problem is the one that I said. What did I say? As discussed in class, write a script to iterate through the entire file system and find the path of all files containing a particular input string. So we kind of did this, you just have to modify it a little bit. And then the second one that I just mentioned was as discussed in class, write a script to iterate through the entire file system and and replace a particular word with an input word of your choice. Now, first of all, this number 3 is a little bit problematic because you're going to need write permissions. Okay, so certainly because you need write permissions, you will not be able to write to every file. And so instead, I'm going to say write a script to iterate through. Don't iterate through the entire file system for this one because you're writing. I don't want you to, by mistake, mess up a file. So let's just say write a directory, write a script to iterate through the entire desktop folder. Let's just say desktop. So your own desktop, right? Desktop folder for your user. Like that. Yeah. So as discussed in class, write a script to iterate through the entire desktop folder for your user and replace a particular word in the file with an input word of your choice. Yes, for you guys, that would be the seed account. That's correct. So when because you're writing, I'm gonna, I'm saying replace. So you're writing, that's problematic and also a little bit dangerous. So only do it on the desktop. For reading, because you're only reading, you could do the entire file system, depending on speed. Does this make sense, guys? So this is so far, these are some of the problems for your homework assignment. For your homework assignment this week, but we will discuss this crystal clear. Awesome. I'm just writing them here so I don't forget, basically. But we will discuss these again on Thursday. So I'm going to share now back to Brightspace. I'm going to add a file. Downloads. Okay. All right, so if we go to table of contents, and then you can see I've added the file now. And so far, these are some of the problems. So problem number 1, I haven't discussed at all. I'll discuss that on Monday. We'll come back, circle around to these, and then I may add one more. But if you want to start working on these, you can. Remember this assignment on Thursday, I'll make it due, and it'll be due a week from Thursday. All right, so great, that's it. So let me go ahead now. Stop this. I'm going to stop the recording.